JPS could actually call us because, you know, whenever there's a major change, they have to check it out. So we have everything to back it up, so we're not worried about that. And so energy conservation actually does make sense, but it's good when you approach it, you know, you're serious about it. If you're easily discouraged, you know, you just change one thing and expect to see a bill change same time, it's not gonna happen. You know, you have to look at your largest loads, focus on those, and once the data shows in the beginning, you know, mathematics, physics, etc., they're very straightforward, and I find it very straightforward. To me, it's easy, because there's a lot of things you have to worry about. You know that if for physics we showed that by putting in this measure there is a reduction, but then when we look at UV bill, it's still increasing. It doesn't mean that physics didn't work. It doesn't mean that the measure didn't work. It just means that you need to do it more, because the first instant worked. So you have to find a way to encourage your management or whoever holds the money, because you need money to do these projects. You have to find a way to encourage them to invest in this. And it has been our investment. And so far, it has proven very well, because we're getting like 11 months payback in most cases. The audit had indicated, I think it said a year and a half. So some of these estimates from Mr. Hartner are conservative. We actually prove that it's much better than that. So that brings me to the end of my presentation. Thank you very much. Okay, not sure how much time I have for questions. Anybody can indicate how much time you think, how many questions I can take? Okay, all right. Could you use a microphone, please?
Donald Ball of Restaurants of Jamaica Limited, operators of Kentucky Fried Chicken. I'm interested in your comparison of LEDs and fluorescent. I noticed you talked about the ballast changing and comparing with the LEDs. Now, LEDs point straight down, whereas fluorescent produce light all around. Mr. Horton mentioned the use of reflectors. Now, when you reflect fluorescent light on two sides, you actually end up with 3 bulbs. I'm not sure if that was factored in any comparison of fluorescent versus LEDs.
Okay, thanks for that question. I can speak a bit more to the LED project. Of the 160 LED tubes we installed, we first did 10. We did 2, then we did 10, and then we went to the 160. Now, what we realized is that when we did the fluorescent, for example, we have a light meter. So we didn't determine for persons to say it looks brighter or it looks darker. We used a light meter, a consistent device that doesn't discriminate, and it measured in lux. We're able to show that in many areas, based on the international standards for lighting, like reading by DEX, we sought for in the region of 540 to 650 lux. We're able to get way over 800 when we put in 4 of the fluorescent. So what we did, we only put in 3. So another part of the project, which I didn't mention in the presentation, is that when we changed out the 4 T12s in some areas, we placed it to 3 of the T8s, because that's the amount of light you really need, because they're brighter. In the case of the LEDs, we realized that even though we'll get in the 800 with 4, if we replaced the 4 with 3, there was a problem because of how the light for the LED was spread. You know that the lights for LEDs are more directional. The tube itself, if you look at it as a cylinder, here being the bottom face and here being the top face, LEDs only have the LEDs on the bottom face, and here is blank. So a lot of light doesn't disperse as it would with a fluorescent. And so we needed, in our case, we didn't necessarily use the reflectors because of the cost, aesthetics, and most of these situations were retrofits. So we tried to still use some of the existing material and devices. So what we did, we used diffusers. And most of the diffusers that we used were among the most expensive types. We used egg-grade silver diffusers. And one of the reasons we had to use the diffusers was that the LEDs also had a higher contrast light. Part of our pilot project was to get qualitative type analysis tests done, where you go to persons from time to time, ask them what they think about the lights. Some persons didn't even look up to see that they were different. So they didn't even know that they were LEDs. But they just tell it straight up that they don't like it. The color is off. You know, they have to focus more. Some people say they've seen the blood in them hand and it's strange because them hand look red. All sorts of stuff. But the bottom line is that for LEDs, you actually need some mechanism in case of a diffuser or maybe your reflector to better channel the light and direct it in the areas that it is needed. And so for the library, areas of the library, West Indies collection at the main library on campus, if you want to visit there, if you go by West Indies collection, you find that they are all A-grade silver diffusers. And that's one of the only way we're able to get the lights soft enough so persons found it acceptable to read and do everything. Don't know if I answer your question. So that's it basically in a nutshell. With 3 fluorescent tubes, we're able to get greater than, most cases, 500 lux. But 3 LEDs gave us the same or more. But because of how the light would spread, we had to use 4. And so in instances where you have LEDs, the lighting levels are in the region of 850 lux, while for fluorescent is in the region of 450, based on the height of the ceiling, to about 550 or 600 lux. So there's actually a difference in the lighting levels, with LEDs being brighter, but more directional and higher contrast than fluorescent, that are also very bright. In this case, the T8 fluorescent, but they're more natural to us. And one more point I must mention, and that is, when you look at the magnetic ballast, they give a flicker, a noticeable flicker. When you turn them on, there's a delay start, they noticeable flicker, and sometimes you can hear them buzzing. With the electronic ballast, that doesn't happen. The light is more consistent, it turns on instantly. And so a lot of the benefits that you get from an LED in terms of power quality and lighting quality is the same as what you get from the T8 fluorescent. And we have values that measure that and show. In fact, our results from our pilot project was that it makes no sense really for us to go ahead with LEDs because we're going to take like 5 years to pay back for this thing when you can be getting payback in 11 months for another measure. And within 2 or 3 years, a sure LED is not going to cost almost $6,000. It might very well cost half the price. So maybe in a few years when the price point, becomes better, it will be a viable option because it in fact uses less energy, but not enough in our mind to warrant the type of large-scale implementations that we did.
A very quick point. The U.S. Department of Energy has determined that LED lamps should not be installed in commercial buildings or offices, the U.S. Department of Energy. And of course, it bears out the same information that I've gathered from them to what Mr. Smelly has been doing locally. So that puts paid to that issue.
With respect to that large project you have been doing at UOE, I know what you haven't seen to capitalize on the time of use energy measurement. You're on rate 50, yes, but in terms of time of use, you have not sought to capitalize on that.
Okay, thanks for the question. Time of use. JP School has what they call time of use. You have peak, partial peak, and off peak. We're able to show exactly how the university uses this energy. Surprisingly, we're very, very, very consistent. As it touches 7:30 in the morning, it's like we're racing up a hill all the way to the top, and we remain there until 3 p.m., and we kind of slowly come off until 3:30, and then by 4:30 going to 5, we fall off, and by 10 o'clock, we're going back down. The bottom line is that time of use really favors persons who have the bulk of their load or activities during the off-peak period. Now, most of UA's activities are doing what you call partial peak, which is doing 7:30 to, 6 a.m. until 6 p.m. And then peak would have been from 6 p.m. until 10. Somebody can help me on that. And then 10 until 6 the next morning will be off. Now, people don't come to class between 6 o'clock, 10 p.m., and 6 a.m. So we ran some numbers. Again, as I said, everything we do, we're an academic institution and tend to talk a lot like that, but most of what I do really is applied research. You run the numbers, they make sense, I report to the barrister, she has the money. So in a way, I kind of have it easy, some people might say.